This is where I left you guys last time. Sort of overview of the tree of different types of fatty acids. We have saturated and unsaturated, mono and poly, and amongst the unsaturated, and then amongst the poly, there's the omega-3 and the omega-6. There was omega-9, which was the oleic acid, but from olive oil, but I'm not making that distinction on this table because I'm not going to really talk about them much more. But I'm going to dive into a conversation about omega-3 and omega-6. And what I'm going to talk about today is I redid the lecture this morning, so I haven't had a chance to update the PowerPoint on Moodle, but I'll do that immediately following class. For those of you who like to have the PowerPoint slides in hand, okay? And I had already talked about this, but I want to start with this again because we're going to be talking about linolenic acid and icosapentaenoic acid and docosahexaenoic acid. This linolenic acid is also called alpha linolenic acid, or ALA, and then the others are EPA and DHA. These are amongst the realm of fats that you, so I'm just going to give you the bottom line to the first part of the lecture here before I dive into the details. And the bottom line is these are what you would call good fats. They are fats that are associated with a wide range of health benefits, which we're going to go through in detail. And they are also fats that need to be obtained from the diet. Specifically, linolenic acid it needs to be obtained from the diet. Humans, just like we had essential amino acids, we have essential fatty acids, and linolenic acid is one of those. EPA and DHA are also essential fatty acids. However, your body can synthesize those if you have an appropriate quantity of ALA. Although this is not to say that having a rich dietary source of EPA or DHA isn't a good thing. And we'll talk about where some of those fats come from in a moment. In fact, now. So the whole notion of essential fatty acids, most essential fatty acids are going to be obtained from vegetable sources. All right. You can get some linoleic acid from animal sources, but if you, so this is an abbreviated version of that table that I showed you towards the middle of class last time, just focusing on some of the polyunsaturated fats. And there are two categories here. There are the omega-6 and the omega-3, reminding you that the omega number just represents how many bonds in from the tail of that fat is that point of the initial point of unsaturation. All right. Two categories, omega-3 and omega-6, and both of them are essential. So what happens if you don't get enough of these in your diet? Well, all kinds of things. You can have problems with your liver, kidneys. For children, these are particularly important. They can lead to reduced growth rates. We need these fatty acids to build the, well, I guess, before I tell you, why don't you tell me, why would you guess that these essential fatty acids might lead to reduced growth rates in children? What do you think? Yeah, Hannah.
If you feel like
Exactly. So, as cells are dividing, cells are growing, we need lipids to make the cell membrane. It can also lead to a decrease in your immune function. These fats, these polyene fats, lead to a host of different hormones, the leukotrienes and interleukins that are going to affect your immune function. They've also been associated, so deficiencies in these these fatty acids have been associated with depression and, not surprisingly, dryness of the skin. Okay. So let's look at these two categories. Let's start with the omega-6 fatty acids. I guess to the benefits before that. All right, avoiding the problems of deficiencies, what actual benefits are they when you have these fatty acids in the diet? Well, one of the things is that they help prevent atherosclerosis, which is a hardening of the arteries. And associated with that, there is a significantly reduced incidence of heart disease and stroke and microvascular disease. People with ulcerative colitis, menstrual pain or joint pain often find their symptoms are reduced by having adequate levels of the essential fatty acids in their diet. And also for women, higher levels of omega-3 fatty acids, particularly the omega-3 fatty acids, are associated with a marked decrease in the risk of breast cancer, which touches many people's lives, sadly. So first, let's talk about the omega-6s and where we get them. So linoleic acid is the primary essential fatty acid. All the other omega-6s on that list there can be synthesized from linoleic acid. Amongst those, gamma linolenic acid, and many of these are sourced in the diet as well. But gamma linolenic acid, the GLA, is associated with reduced risk of a variety of different cancers, an important fatty acid to consume. So where do they come from? You can get them in all the foods that you might intuit to be high in beneficial fats. So leafy green vegetables are high in omega-6s, kale, chard, spinach, etc. And nuts and seeds, so almonds, macadamias, cashews, pumpkin seeds, sunflower seeds, sesame seeds, etc. And a variety of grains are also going to be good sources for these omega-6s. And then a host of vegetable oils. So sunflower oil, corn oil, soy oil, safflower oil, cottonseed oil, a couple others I didn't list on there, sesame seed oil. I will say that most American diets have totally adequate levels of these omega-6 fatty acids. And as I'm going to talk about in a moment, the American diet often has too much omega-6 fatty acids. And that's because we eat a lot of processed food. We eat a lot of food that was fried in some of this oil. The typical American diet. I'm not talking about you necessarily, although maybe you, being healthy young college students, your chances of consuming too much omega-6 are probably a little lower than the average, but I wouldn't be surprised if many of you still have an overabundance of omega-6 in your diet. And as I said, this comes typically from the inclusion of these oils, these vegetable oils in particular. It's not because America is eating too many leafy greens. It's because America is eating too many foods that are deep fried in these various vegetable oils here. Now, particularly corn oil. All right. So the omega-3s, the sort of mother omega-3 is the alpha linolenic acid, ALA, and it is the essential fatty acid that's used to make the other omega-3 fatty acids, such as the eicosapentaenoic acid and docosahexaenoic acid, the EPA and DHA. Where do we find these? Well, here are some sources. Soybeans, walnuts are particularly high in omega-3 ALA, and deliciously, winter squash. What a fun one to eat. What a great way to get your omega-3s. Flax seeds and flaxseed oil. So I asked people yesterday if anybody here eats flaxseed oil, and I think you said you eat flax seeds. Yeah, nobody else has really spoken about them. Maybe next year I'll build a lab around flax somehow. But flaxseed is a really easy thing. Yeah, Peg.
Why for flaxseed? You from the seed.
To say that you don't get the nutrients isn't quite correct. So flax seeds are an amazing source of soluble and insoluble fiber, right? And so the benefits that you get from flax from their fiber content is probably just as important, if not more so, than their oil content. The oil, without putting a diagram of the flaxseed up there for you to inspect, it's not tremendously different than the cross-section of the wheat berry that we put up there. So the oil is mostly contained in the germ of the seed and a little bit in the endosperm, but not in the bran along the outside. And they're pretty tough little buggers if you've ever messed with a flax seed. So if you're not breaking that shell that is covering the flaxseed, pardon me, I ran through the cold today. I got myself a little asthma. If you are not breaking that shell, you're not liberating the oil that's inside the flax. So it just passes through your colon. But, you put a bunch, like, Wes brought in a big bowl of oatmeal. You dump 3 tablespoons of flaxseed over that and stir it in. You won't notice it's there. It will change the texture a little bit. But if you chew that up, you're certainly going to get a reasonable amount. Not the same amount as if you stuck it in a coffee grinder and buzzed it up and then mixed that into a smoothie or something like that. But, certainly a lot better than not getting any. And having the whole seed gives you access to a lot of the mucilaginous soluble fiber that you'll notice when flaxseed has been soaked. So if you ever take a teaspoon of flaxseed and you soak it in water or something like that, after, 15 minutes, you'll see that it's a really weird slimy paste. And that's from the fiber that's on the outside, the soluble fiber that's on the outside of the husk. But inside's the good stuff. And so if you're eating flaxseed specifically for the oil, the best thing to do is to get cold pressed flaxseed oil and keep it in your fridge or even your freezer. And then just use that as your salad oil instead of olive oil or whatever. And you'll get more than enough omega-3s that way. And we'll see why in a moment. I'm going to show the breakdown in some foods in a bit. Also, black beans are a good source of omega-3 fatty acids. All right. So there's a category of food that is conspicuously absent from this montage, this photo montage I have up on the top here. Can anybody guess what that might be? Yeah, fish. Everybody says, wow, omega-3 fatty acids. I'm going to take some fish pills. I'll address that question, why I didn't put that photo up here in a moment. Certainly fish are a rich source of omega-3 fatty acids, but I'll talk about that in a moment. In fact, this moment. So when considering these essential fatty acids in the diet, the one thing that you need to, one consideration that is paramount is the ratio of omega-6 to omega-3 fatty acids. So there have been some estimates that the ratio of omega-6 to omega-3 fatty acids, so that's omega-6 linoleic acid to omega-3 alpha-linolenic acid, should be anywhere from 1 to 1 upwards to 4 to 1 would be the upward bound of the relative amount of alpha-6 or omega-6 acids that you'd want in your diet. Why is this? Well, omega-6 fatty acids tend to compete with omega-3 fatty acids for utilization in the body. And if you have too much omega-6, if you have too many omega-6s, it outcompetes the omega-3s for incorporation. The typical American diet, so I just told you that ideally it's a 1 to 1 or a 4 to 1 ratio of omega-6 to omega-3. Typical American diet is anywhere from 10 to 1 to 25 to 1. So that's a problem. Even though omega-6 fatty acids are beneficial, they are essential, there is such a thing as too much of a good thing. So here is, I wanted this slide to have more data than it has on it, but I kind of ran out of time. But I do have this picture here, for example, as an example of one of the food choices that you could make. If you're going to eat beef, there certainly is omega-3 and omega-6 fatty acid in beef. However, beef is not an excellent source necessarily of these fats, but they are a source, right? Which should make sense because I just told you they're essential. Your body needs them. Your body incorporates them into your cellular structure. And why is it any different for cows, right? So beef is a source of these fatty acids. If the way the beef is fed determines their relative ratio of fatty acids that are incorporated into their cells, just like it would for you. I've just talked about the ratio in humans as being important. If you're going to eat a meat source that has the ratio, that reflects the ratio that you want in yourself, okay? So if you're feeding beef nothing but corn, like they do here in North America, then the ratio of omega-6 to omega-3 is 17.7, almost 18 to 1. I just told you that the typical American diet is anywhere from 10 to 1 to 25 to 1. And so that ratio falls squarely within the ratios of the typical American diet. Whereas grass-fed beef, the way they consume or raise beef in Europe, for example, it's 1.7 to 1. So that's within a reasonable ratio, a reasonable range. All right. In lab on Friday, we're going to be taking samples of our hair and trying to package them up and send them off along with the scobies. And I told you one of the things that we can do is track what continent you've been living on, what continent you've been eating food on, by looking at the carbon ratios, carbon-13 ratios in your hair. It's because of this right here. It's because of this. American beef is corn-fed. That's a C4 plant, whereas grass-fed beef, grass is a C3 plant. So that carbon signature is going to turn up in the beef that we eat, and then it's going to be reflected in you and then your hair is coming out of you, so it's a part of you and reflects what you eat. You are what you eat. Okay, so this is related to what we're going to be taking a sample of in lab on Friday. All right, how do you deal with this? Well, food choices. Eat minimally processed foods that have a lot of naturally occurring omega-3 fatty acids. If you can lower this ratio, it's going to reduce the risk of a whole host of chronic diseases. A lot of pro-inflammatory diseases. Everything from arthritis to cancer to heart disease, etc. Long list, okay? So I have an avocado and a fish up here. And I had asked you about another source of omega-3 fatty acids. Avocados are a lovely source of omega-3s, as are fish. Well, would you guess, you're all pretty smart in here, so you're probably not going to let me trap you with this question, but I'll pose it anyways. Which would you rather have as a source of omega-3 fatty acids? An avocado or a fish? What do you think? Take a chance. Don't be shy. You guys aren't shy. What do you think? Damon, go for it.
Did you say that have?
Sure.
So isn't there one used by your body?
The fatty acids are probably equally accessible in those foods. They're equally accessible in those foods. Yeah, Hannah.
I would get the avocado.
Okay, why would you guess that?
I mean, it has, but just talking not putting.
Clever girl, yes. Yeah. I'm not going to tell you that fish is bad. All right? That's not what I'm going to tell you. And in general, I try to shy away from making nutritional statements in this class that are on the edge of research and understanding, right? Telling you that you shouldn't eat, deep fried mac and cheese balls off the buffet at Old Country Buffet every day. That's not a particularly edgy statement, and I'll stand by that, right? But for me to tell you that it's not healthy to eat fish, that I would have to equivocate that statement quite a bit. But I will say this: that fish, there are some problems with fish, right? So first of all, when you're eating fish, you are certainly getting lots of cholesterol with that fish as well. So there are other lipids that travel with the beneficial fats that are in fish that you have to take into consideration. Secondly, fish oils in particular, so fish has EPA and DHA, which are both really beneficial. There's no question about how powerfully beneficial they are for the body, except these fish oils are particularly unstable. They are particularly prone to heat degradation. All right, they're very, very unstable and easily go rancid. This is why if you go to the store and you buy fish oil pills in gel caps off the shelf at your pharmacy, you might as well save your money or just give it to me. I'll take it and make you feel good by telling you some jokes, because the fish oil that's in those pills, that EPA and DHA has likely been degraded because it hasn't been kept at an appropriate temperature to prevent isomerization. So we talked about cis versus trans isomerization. All right. I'm not saying there's not there wasn't plenty of EPA and DHA in those pills to begin with, but it's probably been isomerized to trans fats because of the temperature, or degraded to give rise to different free radicals, oxidizing free radicals, which are definitely not things that you want to be consuming. Okay, so what about fresh fish? What about I'm going to go out to the Gulf of Maine, take my fishing pole, put the mackerel jig on there, sit out, on a long dock and jiggle my thing, and boom, get 5 mackerels on my hook all at once. That's amazing, really fun thing. You yank them in, and you have these fish. You cook them up, or maybe you want to go eat some sashimi, mackerel sashimi. That's cool. Well, comparing them to an avocado, first of all, you're much more likely to get mercury out of the fish than you are the avocado. So that's a consideration. Not all fish has mercury, but much of it does, because our oceans have in places have high concentrations of mercury. And then fish have no fiber in them. They have no fiber to speak of. And avocados are actually quite high in fiber. So thinking about the whole food source is an important thing when you're talking about where you're sourcing your essential fatty acids. This is not to say that you should never eat fish. Please eat fish. Fish is an excellent choice to make once a week or something like that. But yep, Damon.
So just like I know you said fish also.
That's right.
Yep. You said also that like the EPA,
DHA. Yeah, the icosapentaenoic acid and docosahexaenoic acid, the two omega-3 fatty acids, the really long-chain ones.
Get degraded when you eat them.
Yeah. So avocados don't have a whole lot of EPA or DHA in them, right? But they can be synthesized from the ALA that you find in avocados. But fish is a direct source of EPA and DHA. But it's unstable. Yeah. So I mean, if you're going to eat some fish, eat like a nice chunk of fresh sashimi sushi, and get it. Hopefully, that comes with its own problems. Fish has a sustainability issue. We're definitely fishing the oceans out, so make sure that fish was sustainably harvested if you can as well. We benefit from being a wealthy country and able to consume a lot of sushi, high grade fish, but the impacts on the not just sushi. I mean, actually, sushi is probably a very minor component of the American fish consumption, but the fish choices you make do have direct impacts on the oceans. So, yeah.
I'll add a shot of cod liver to weight off.
Yeah.
It's like a vitamin.
It's going to be there is going to be a vitamin D component to depression, but the cod liver oil is an excellent source of of omega-3 ALA and EPA and DHA, which are going to be also important in warding off the depression. Yeah, so that's an interesting little nutritional vignette there. Did you partake in any of that? You take a little shot of cod liver oil. You ever had that? What'd you think of that? It's kind of gross. Yeah, it's kind of gross, but works, I guess. All right, so let's look at some foods. Now, on this range, the ones that have more blue tend to be vegetable oils, and the ones that have more red tend to be more animal products, although there's actually only 2 animal fats on this list. It had another slide that that spectrum on the bottom went to, but I cut that slide out. Anyways, what are we looking at here? Well, we've just been talking about the omega-3 to omega-6 ratio. And that ratio is the blue to the sort of darker mustard color or the darker orange color, right? So you want foods that have a 1-to-1 or a 4-to-1, or even better, to remediate your diet, a higher ratio of the omega-3. So you want foods that have a lot of the dark orange and a lower quantity of the blue. And also keeping the saturated or red fats to a minimum. So the third one down is really the winner, isn't it? That's flaxseed oil. And it is 53% omega-3 fatty acids, ALA. So flaxseed oil really is an excellent source of this. They don't put I don't have a hemp seed oil on this chart, but that's also another source of ALA, an excellent source of ALA. So this really begins to tell you if we look at this closely, let's compare safflower oil to flaxseed oil. All right, safflower to flaxseed oil. So safflower oil has about the same amount of saturated fat, about the same amount of omega-6, but it's in the monounsaturated fats where there's this profound difference. There's virtually no omega-3 ALA, whereas there's plenty of other monounsaturated fats in the safflower oil. And if we take that and then compare it to the nutritional label that is dictated to us by standards set by the Food and Drug Administration, you see here that it talks about total fat. They tell us the total amount of fat in grams in the food, and then it gives us a percent of what they say you should you should eat in a day. That's marginally useful. But then they tell us the amount of saturated fat, okay? And they tell us how much of that is trans fat. So if it's a processed food, you're going to have some trans fat, and if it's an unprocessed food, you should have no trans fat there, right? Because trans fat is not naturally occurring. And then they tell you the amount of cholesterol that's in the food. It tells you nothing about the kinds of unsaturated fats that you have there. You can infer that in this nutritional label on the left, which is for Irish unsalted butter, that there are 4 grams of polyunsaturated fats, or some kind of unsaturated fat. And that's about 2/3, which matches the histogram on the left-hand side that says about 30% of butter is some kind of unsaturated fat. But it tells us nothing about the profiles of those fats, which is what you actually want to know. Yeah.
So the darker on the bottom is
Yep.
So why, or I guess I'm comparing butter oil,
Mm-hmm.
like butter.
Mm-hmm. Yeah, so if you look at the vegetable oils that are on the bottom of the chart, where there's more saturated fat, I could have put another axis or another sort of thread on that bottom spectrum that I put down there. It could be vegetable and animal. I could also have put temperate versus tropical, right? So temperate vegetable sources tend to be more polyunsaturated, and tropical vegetable sources of fat tend to be more saturated fats.
So
Right.
that's like a general.
Yeah.
That's not like a hard.
No. No, those are trends. Yeah, those are trends. Yeah, I should. That's a note to myself. I'll make sure to amend that so it's more clear. It would have been more clear if you had seen the other slide that I had. I kind of hastily threw this slide together. But palm oil and coconut oil are both tropical oils, and I talked last time about the melting point of fats and their degree of saturation or unsaturation, and why a tropical oil would want to have more saturated fats in it. So even just saying a saturated fat, there's a lot of different kinds of saturated fat, all right? And I also had talked a little bit about caprylic acid, the short chain C8 fatty acid. And that, the effect on the body of a C8 saturated fat caprylic acid versus some of the longer chain fatty acids is going to be distinct. So even this chart is not giving you all the information that you need to really be able to compare the different fats. So like that 63% in butter that you see there, and then the 87% in coconut oil, those two red bars, those are not the same fats. And I mean, there's going to be some overlap, but they're really distinct, distinctly different profiles, those fats. Does that make sense? Okay. So we've made a big deal about this saturation and unsaturation. Well, like, give me why. I don't understand why. Well, let's just think about biophysics for a moment. What these fats are actually doing. In saturated fats or animal fats or these tropical vegetable fats that we were talking about, they're fully saturated. And last time I handed around that fat and asked you to tell me what was unique about that double bond. You couldn't rotate around it, right? So that fat had a kink in it. It had a weird kink in it. It's kind of hard to pack fats with a kink in it together. But the saturated fats, where the bonds can all rotate freely and find the lowest energy position along their length, it's really easy to pack those together, okay? So, for example, let me think of an example. Imagine you had a long metal chain. You had a long metal chain. You had a bunch of them, a bunch of long metal chains, and you were going to pack them. You could line them all up and stack them in a box, all parallel to one another, wrap the box and ship it off. Or imagine you took those chains and you were to weld the links together and made some kind of like chain art. I don't know what it is. You're making some kind of chain art, but the chain is frozen in a certain orientation. Same amount of links in the chain, same mass, etc., but radically reduced degrees of conformational freedom, right? You can't just line them up in their perfect orientation. And say you had to ship the same amount of chain somewhere, but now they've been welded into this chain art. You're going to have a much harder time packing them together in a box, okay? And it's the same thing here. With saturated fats, they're able to line up right along one another, and they have lots of hydrophobic interactions along those yellow, fatty hydrophobic chains right there. Those hydrophobic interactions that are bonding them together, that are holding them together, that is what makes saturated fats have a higher melting point, right? Because it takes more temperature, more heat to overcome those hydrophobic interactions between those chains and melt them and turn them into a fluid liquid. So at at higher temperatures, fats, as opposed to oils, fats, which are saturated, are packed together with lots of hydrophobic interactions, giving us the solids that we're familiar with. On the other hand, unsaturation, it's these weird kinks, these cis kinks in the lipids. The double bonds are cis to one another, so the fats are kinked at these weird angles, and they don't pack together especially well. We have a reduced density of hydrophobic interactions between those hydrocarbon tails, and consequently, you have a lower melting point. So at room temperature, these are oils rather than fats. Okay? You can also begin to appreciate that if you do heat those cis fats up and isomerize them to trans fats, that it's going to lock that fat into the orientation of a saturated fat and keep it there. So trans fats tend to have higher melting points than cis fats, all right? And they also have deleterious biological effects because they mimic saturated fats, and they have other things, other properties as well. But one of them is that they mimic saturated animal fats. That's the trans fats. Okay. So let's look at these melting points. Did I not talk about melting points already? Maybe I didn't. Sorry. Okay, that's me remembering making a slide, but not remembering talking. Okay, well, anyways, the point is that yes, saturated fats have higher melting points and unsaturated fats have lower melting points. This is why lard and butter are solid at room temperature, whereas olive oil and corn oil are liquid. They're oils. So let's just look at this. We see lard, pork fat, on the left-hand side. Its melting point is 34 degrees C. 34 degrees C is what, like 100 and some change Fahrenheit? And solid at room temperature. And it has 41% of it is saturated fats. Butter is 68% saturated fat, also solid at room temperature. Now let's go to the bottom of the thing. We've got corn oil. Its melting point is at minus 20 degrees C. So if you were to take corn oil and put it in a really, really cold freezer when it got to minus 20 degrees C, which is extremely cold, right? That's extremely cold. No normal household freezer. I mean, the household freezers are minus 4 degrees, right? So this is really cold. That fat, the corn oil, has 58% polyunsaturated fatty acids. The cod liver oil that Wes was talking about freezes at minus 5 degrees centigrade. So if you were to take that cod liver oil, you could keep it in your freezer and it would still be liquid, but just barely. It would be a very viscous, thick liquid, just above its melting point. All right? And it does have a high degree of monounsaturated fatty acids. So one thing that you might notice here, and this gets to Hannah's question earlier about coconut oil and butter. If we compare butter fat and coconut oil, the saturated fats, coconut oil has a much higher degree of saturated fatty acids, which is what she initially noticed. However, coconut oil has a lower melting point. It has a lower melting point than the butter fat. And why is this? So essentially, if you look at the two profiles, butter fat has a little bit of polyunsaturated fat. Coconut oil has virtually none. And it has much more monounsaturated fat than coconut oil, which has only 8%. And butter fat has considerably less, about 25% less saturated fat than coconut oil. So why is butter fat's melting point higher than coconut oil? That is because exactly what I had said, the length of the saturated fats. There's just different types of saturated fats. The saturated fats that are in butter fat are considerably longer, and the ones in coconut oil are much shorter chain, medium and shorter chain saturated fatty acids. Why is that? Why would you guess? Put on your critical thinking caps. Why is that going to dictate the melting point temperature? What do you guys think? What did I say when I showed that last slide, when I was talking about those long hydrocarbon tails stacking up next to each other in the saturated fats, and those hydrophobic interactions giving rise to the that's like breaking those. That's the energy that you are required to put in when you're heating a fat to melt it, right? So why would shorter chain fatty acids have a lower melting point than longer chain fatty acids. What do you think? Yeah, there's less hydrophobic surface between those lipids to overcome when you're melting it. So just looking here, just at the melting point, that's, again, a hint at what you were asking about earlier, data that wasn't shown in the previous table. They just look like saturated fats. Not all saturated fats are the same, okay? Not all unsaturated fats are the same. All right, so let's keep plowing through this. We can take unsaturated fats that we get from various oils, and we can hydrogenate them. You've probably heard about like partially hydrogenated vegetable oil, right? You can change the physical characteristics, the melting point characteristics, the smoke point when you're frying with an oil. You can change all of that by hydrogenation. And the way we do this is chemically, not we, but the way scientists do this is they take some kind of metal catalyst. And so I'm showing on the right-hand side a nickel, palladium, or platinum catalyst. It's this metal surface that has been hydrogenated. It's got hydrogen attached to this metal surface. And that metal really likes the electrons in the double bonds between the carbon. So we take oleic acid, which is a cis. It's that same carbon, the same 18 carbon fatty acid that we've been looking at several times. We looked at several times on Monday, but it's a cis fatty acid. And then you expose it to this prepared catalyst, and it breaks the double bond that's at the C9 position. Yeah, oleic acid is an omega-9 fatty acid, and converts it to stearic acid. This is a saturated fatty acid. So that's fine. We're making saturated fats out of unsaturated fats. But one of the problems is sometimes the fats don't become saturated. And in fact, what happens instead is these catalysts are able to isomerize it, and they cause an isomerization from a cis fatty acid. So on the bottom you see, again, oleic acid, and the catalyst transforms it into an 18-carbon trans fatty acid, an omega-9 trans fatty acid. It's essentially the same fatty acid as oleic acid, but we call it alaitic acid. It's a trans fatty acid. So a lot of partially hydrogenated vegetable oil isn't really that good for you because it's going to have more saturated fats in it, first of all, and secondly, it's going to have more trans fats in it. All right. This is where the problem with processed foods really comes in. Okay, so there's a lot of this technique of processing oils for different food applications leads to fats that are really deleterious to your health. Any questions on this process? You guys learning stuff here? Is this all old news for y'all, or is this you guys understanding something new about the food you eat? Good. All right. Wait, I said you're a good kind of fat. Should have started with the class, but maybe we need to laugh now. All right. What's the deal with this? I'm not going to get a chance to really slam this point home. Maybe I'll do a little bit, and then we'll pick up with it next time. But these trans fats, they are a big, big problem. They are a big problem. Coronary artery disease and myocardial infarction are one of the biggest tolls that trans fats inflict on America. So I believe this is 2014 stats. 616,000 people die every year from heart disease. That's 25% of all U.S. deaths. 1 out of 4 people die because of some kind of heart disease. It costs America almost $1 billion a day in medical costs and lost productivity. Think about that. $1 million a day. Billion dollars. Sort of staggering to me. Let's look at this map of heart disease rates across the country. It tends to be focused in the South, in the deep South, where there's a lot of Southern cooking, Paula Deen, the Paula Deen diet, high saturated fat. It also tends to track with poverty, which is why Maine is higher amongst the New England states in terms of coronary artery disease. All right, that's the end of class. I went a minute over. We'll pick up with this a little bit next time.